Okay, so this is lecture 2 of Engineering 126, and in today's lecture we are going to start looking at C++ programming. Okay, so we're going to start off by putting up a sample C++ program. Okay, so this is a very simple program, and all it's supposed to do is take 2 points in the two-dimensional Cartesian coordinate space, right? So these points have x and y coordinates, and then it calculates the distance between these 2 points. Okay, and before we get into the details of this, let me just quickly describe exactly how the calculation is going to work. Okay, so conceptually, we have our Cartesian coordinates space, right? So the horizontal is the x-coordinate. The vertical is the y-coordinate, and we're going to have 2 points. Okay, so this could be point 1, let's call that P1, and then maybe a point here is P2. Okay, point 1 has coordinates that we're going to call x1, y1, and then P2 has coordinates that we'll refer to as x2, y2. Right? If we wanted to calculate the distance between these 2 points, right, it means we're trying to measure the length of this line that joins the 2 points. And the easiest way to do this, okay, is by looking at this line that joins the 2 points as the hypotenuse of a right triangle. Okay, so you draw a right triangle, and if we could somehow find the length of the 2 sides, then use Pythagorean's theorem to find the length of the hypotenuse, which is the distance between the 2 points. Okay, so we can go ahead and call, let's say, the horizontal distance side 1, and call the vertical distance side 2, where side 1 is simply the difference between the x-coordinates, right? So this could be x2 minus x1. And then side 2 is the difference between the y-coordinates, y2 minus y1. Okay, and now the distance can simply be the square root of side 1 squared plus side 2 squared. Okay, so conceptually it's very simple. Right? Now, how do you get a computer program to do it? A computer program, of course, is something that someone has to write. Right? Someone had to design this program, and usually you design it based on a certain need. Right? So some programmer might have decided, well, there's a need to calculate the distance between 2 points in the 2D space. So since this type of calculation is done over and over, it will be of great benefit to write a program that will automate this for someone who wants to do this calculation. Right? And once you have the program written, then you can simply run it over and over every time you need to calculate the distance between 2 points. Okay, so that's the whole idea behind writing a program such as this. All right, so now if you were to do this by hand or even to use a calculator, you know the exact steps, right? You could even skip certain things like coming up with these 2 names, side 1 and side 2. You could go right in and plug in all your numbers, take the square root, right, and come up with the distance. But when a computer is asked to do something like this, it's a lot different. Okay, so here's the thing about computers, right? Last time we said that a computer at its very core is simply a bunch of on and off circuits, a bunch of switches that can be turned on and off. All right, so that's all a computer understands: is something on or is it off? Is it true or is it false? Right? Is it 0 or is it 1? So what that means is a computer does not have any flexibility, it doesn't have any creativity like the human brain does, right? To a computer, everything must be black and white, okay? You have to tell it exactly what to do. So in a computer program, okay, the programmer has to go through and lay out step by step exactly what the computer has to do. All right, the computer can't really think for itself. It must be told exactly each step of the process. All right, so this is the program then, okay? And if you kind of scan through this program, you're gonna notice a couple of things. First thing is that there are actually things that you can make sense of, right? There are actual written sentences, if you will, right? And there are even words that you can pick up. Okay, so that's the first thing. The second thing that you might notice is that there's some math that's being done here, right? And you could actually make sense somewhat, right, of what that math is. So you see math equations, for instance, right? You see these equations for side 1 and side 2, and then you see this calculation for the distance, right? And you could kind of guess that this word here, SQRT, stands for square root. All right, now this is not the whole program. It continues on to the next page. Okay, so let's scroll to the next page, right? And that's the end of the program. So this is the whole program, all right? Now, a lot of what's going on in this program probably doesn't make sense if you've never seen computer programming before, or if you've never seen C++ before. Right? So we're going to go through this line by line in a little bit. All right? But before we do that, okay, let me talk a little bit about what a computer language, right, really encompasses. Okay? So C++, as we mentioned last time, is a programming language. And the important word here is language. Right? So by language, right, we're referring to something that's very similar to a spoken or a written language, such as English, or French, or German, or Japanese, right, whatever, okay? And what are the features of every language, every written and spoken language? Well, it's got a set of vocabulary, right? There are a bunch of words, usually hundreds, if not thousands of words, and then there are grammatical rules for how you write, sentences and paragraphs, right? And how you write literature, even, right? So there are all these rules as far as structure, punctuation, grammar, and what have you. Okay? So some of the things about languages is you can use only words that are available in your language, right? So you can't come up with your own words. That's a very important rule, okay? And then we already mentioned this whole idea about punctuation and spelling and grammar and whatnot, right? So C++ and every computer programming language follows these same features, okay? It's got a vocabulary. It's got a bunch of rules regarding punctuation and structure and grammar, okay? And that makes it very similar to something like English. Now, what are the differences? Well, we had said that computers are very rigid, right, very strict. Everything is either right or wrong, black or white, as far as a computer is concerned. So, whereas in English, right, when you took high school English and you were asked to write a paper, if you made some mistakes in your paper, right, maybe you misspelled certain words, you left out commas somewhere, you didn't really write in paragraph form, right? You use improper grammar. Even if you made a bunch of those types of mistakes, your teacher was still able to read your paper and understand exactly what you were trying to communicate, right? In programming, that is not the case, okay? You can make a very simple mistake, such as you just misspelled one word. And that very simple mistake will have huge consequences, right? And what that really means usually is your program won't run. You try to run that program and the computer says, I don't understand what you're trying to tell me because I don't understand this word, okay? So you must follow the rules of C++ programming exactly as they are, as they're stated, okay? You can't come up with your own rules. You can't break any rules, okay? If you make mistakes and you break some of these rules, okay, one of two things can happen. The first thing is you end up with what we call a syntax error. All right, so let me write down the word for you. Syntax, S-Y-N-T-A-X. Okay, so a syntax error is an error in spelling, in punctuation, or in grammar, right? And basically, you've broken one of these very strict rules, and the computer isn't able to understand what you're trying to tell it, so your program won't run. Okay. The other type of an error is what we call a logic error, right? And the logic error is very different, and it's actually much tougher to deal with than a syntax error. So a logic error, right, basically results in a program that still runs. Okay? There are no syntax errors. You haven't broke any rules of the language. But you probably made a mistake maybe in a calculation and in an equation, right? In the way something is supposed to be structured. And what happens is the program runs, but it gives you the incorrect result. Okay? A situation like that is very tough because as far as the computer is concerned, there are no mistakes, right? All the rules were followed. But for you, the user, the programmer, you know that there was a mistake because the results are wrong. Okay? And why is this so much harder? Because now you have to go through your program, right? Line by line, usually, right? And try and find exactly where that mistake was made. Okay? And that can be tough because something like a syntax or a spelling error could be pretty easy to catch, right? You use a spell checker, right? And you should be able to catch your mistakes. But something that's an error in logic, right? You're kind of left on your own to try and figure out what that error is. Okay, so we'll get into the different types of errors as we go through this course, right? But that's what you're going to encounter. Okay, programming, probably more than half of programming is actually correcting your errors. Okay, we call that process of finding and correcting your errors debugging. Right? You've all probably heard of this term before, but debugging is a big part of being a computer programmer. Okay, if there was no debugging that's required, then programming would be a much easier endeavor, right? A lot more people would probably be programmers because then you just simply write a program and you don't have to worry about trying to correct any mistakes. It just runs, right? All right, so that's a little bit about what we mean, right, when we refer to C++ as a programming language. All right, so let's continue on. Right. So with all that in mind, we're going to go back to the sample program that I put up earlier, right? And we're going to go through this line by line, okay? And we'll discuss exactly what each line means. And that should give you an idea of basically what goes into writing a C++ program, right? Look how many lines are in this program. It's quite a bit. This is supposed to be a very simple program, right? You have 2 points with x and y coordinates, and you apply Pythagorean's theorem to come up with a result. And yet, to do something that's simple, you could see that there's a whole lot of code that's required. Okay, so what I want you to keep in mind as we go through this, right, is those few points that I made earlier, right? You have to be very strict about following the rules of C++, and in any computer programming exercise, in any program that you write, keep in mind that a computer has to be told exactly step by step what it has to do, okay, what you want it to do. Okay, you can't skip any steps when you write a computer program, all right, because the computer is not able to fill in the blanks for you. It's not able to kind of make any deductions on its own, right, as to what you want it to do if you don't tell it exactly what it's supposed to be. All right, so let's start going through this line by line. the first 3 lines, actually, other than the slashes and the asterisks, those 3 lines look like regular English, right? They say, this is a sample C++ program, right? I probably should have ended that with a period, but that's okay. So that's an error probably, right? If I were writing an English paper, my English teacher would probably said, you lose a point for leaving a period out of that sentence, right? But you still understand what that's saying, right? And then the next 2 lines basically say, it calculates the distance between 2 points. Okay, fine. Everybody knows exactly what this means, right? Now, does a computer understand what this means? So the answer is no, right? This is actually not C++ code. It's not any type of computer code, right? So this is what we call a comment. And a comment is not meant for the computer, okay? It's not part of the program, really. A comment is more meant for you, the programmer, or it's meant for someone who's going to be reading your program, okay? And why are comments necessary? Well, you know, it should be pretty obvious to you that computer programs can get very complicated, right? If you start writing a very long, complicated C++ program, there's going to be a lot of things going on. And if you were to give that program to someone else, it could even be someone who's programmed for 10 years, right? Who's a absolute C++ expert. You give that to them, and they're going to have trouble trying to make heads or tails out of what your program is doing, right? They would basically have to sit down and basically look at your program in detail and break it down line by line before they know exactly what your program's doing. So the whole point of using comments is to help people understand exactly what different parts of the program are doing, okay? So it just makes it easier for someone who's reading your program, right, to be able to understand and follow what exactly is going on. So in every program you write, it's a good idea. It's what we call good programming practice to put in as many comments as you feel is necessary to help people along, right, if they were reading your program. So in most programs, what that means is you start off at the very top, right, with a comment that describes exactly what the program's going to be doing, right? So that's exactly what this is doing. And I would suggest that you do that. In the past, I see a lot of students when I give programming assignments, right? They start off their program with basically a copy and paste of the assignment. Like I'll post up an assignment, right, that says write a program that does this, this, and this. And these students will copy exactly that assignment that I've posted up, and they put that in. That's the very first comment in their program. That is an excellent idea, right? Because now you have that available to you as you're writing a program. You know exactly what I'm asking you to do. And if you were to give that program to someone to read, they could read that and know exactly what the goal of the program is, okay? So how do you put in that type of a comment? Okay, so this is the first rule, if you will, in C++, okay? To put in a comment, you write a slash, right, followed by an asterisk, and what that tells the computer is once it encounters the slash and the asterisk, right, the computer then knows to ignore everything that comes after that. It's not meant for the computer. It's meant for humans, okay? And once you put in that slash and the asterisk, then you can start typing whatever you want, okay? Now, the way I've done this, right, I wanted to show 2 different ways of doing this. So what you'll notice is that at the end of that first line, I put in an asterisk, then a slash, okay? So that's what the computer looks for, to indicate that it's the end of the comment, okay? And then it ignores everything in between. All right, so the way this is going to work then is the computer takes this whole first line as a comment, it just ignores it, then it goes to the next line and it sees the slash and an asterisk again. So it says, okay, this is also a comment, right? And it'll ignore this whole second line. And you notice that I didn't put an asterisk slash there. So what happens is it jumps to the next line, but because it hasn't encountered the asterisk slash yet or the end of comment yet, it continues to treat this third line as a comment. Okay, and then finally it encounters the asterisk slash, and it knows, okay, that's the end of that comment. All right, so that's just to illustrate something here that I'm going to point out. All right, if you have a very long comment, you do not need to indicate that every single line is a comment. All you need to do is put at the very beginning the slash and the asterisk. Then you could type multiple lines of comments. Okay, I don't care how many lines you type. And then at the very end of that comment, you just put in the asterisk slash. And then the computer says, okay, I ignore everything in between the slash asterisk and the asterisk slash. Okay, so that's how you comment. All right, so that's the very first thing. The next two lines. And you'll notice I left a space, right? That's a good idea. In C++ programs, right, when you leave a space, the computer just ignores the space, okay? A space doesn't really mean anything. So do you need to put these blank lines? Technically, no, right? They don't do anything as far as the computer is concerned. But for readability, right, if you're going to give this program to someone else, or even if you're going to put this program aside and come back to it maybe a few months later, it's a good idea to leave these blank lines. It just makes the program easier to read. All right, so that's also good programming practice. All right, so we're going to forget about the blank lines, right? They don't mean anything, but they're just there to help this, help things stand out. Okay, so we go on to these next two lines. There's a bunch of different ways now, a bunch of different names for this symbol, right? These days, that's called a hashtag, right? It's also called sharp, okay? That symbol, it's also called a number symbol, right? I don't care what you call it, but that symbol with the word include, right? And then you see the less than sign, then the word IOStream, then the greater than sign, right? And then the line below that is very similar, but instead of IOStream, you see CMath, okay, within the less than and greater than signs. Okay, so I'll talk about that in a few minutes, right? But you can see what follows after the less than symbol, right, or the greater than symbol, right? It's this. 2 slash marks, 2 slashes, okay? So that is the other way that you could put in a comment in C++. So what is the difference between putting in 2 slashes and using the slash asterisk and the asterisk slash? Well, there's a very subtle difference, but it's an important one, okay? When you put 2 slashes, basically that tells your computer, ignore everything on the rest of this line. Everybody see what that means? All right. So in these two lines, the include IOStream and the include CMath, those are actual C++ commands. The computer actually tries and interprets those commands, right? But then it keeps going, and then it encounters the 2 slashes. And those 2 slashes tell it that the rest of that line is a comment. So the computer ignores what comes after the 2 slashes. Then it goes to the next line, and now it knows that that's no longer a comment. Okay? So the 2 slashes are used to place comments on the same line as actual C++ code. All right? When you use the slash asterisk and the asterisk slash, you don't put any C++ commands along on the same lines as those comments, right? But when you put the 2 slashes, that means those are actually being comments that are being put on the same line as C++ commands, okay? So what I'm going to do here is, rather than going through this line by line using my pointer, I am going to go a few slides down, because here I've actually now copied some individual lines, and then I start to describe each of those lines. Okay, so this might be a little easier for me. All right, so I already talked about the first 3 lines, the comments. All right, here, these are the 2 lines that we're looking at currently. All right, I talked about the comments, right? How the 2 slashes are comment. But how about the include and the iostream cmath commands? Okay. So the whole idea behind these 2 lines is this. Okay, as this slide says, C++ has a lot of built-in functions or a lot of built-in commands, right? And there's a whole bunch of them, probably a couple hundred, right? Now, are you going to need every single one of those commands in every program that you write? The answer, obviously, is no, right? If you're writing a very simple program, you don't need all these, complicated built-in commands, right? So what C++ has done is it says, there are all these built-in commands, and they take up resources, right? If every single program that you write had access to those commands, you're using up a lot of memory, right? And you're doing it unnecessarily because you never make use of those commands. So what C++ does is it starts grouping all those commands into a bunch of different categories, right? And then you tell the computer which of those categories you want to make use of in your program, okay? And if you don't specify that you want to use a certain set of commands, then it's not put into your program, and you free up resources. Makes your program run a little faster, okay? So iostream and cmath are 2 groups of commands that are built into C++, okay? And they stand for very different things, okay? iostream, okay, you will see, if you look at the comment that follows after that, it says iostream is required for cout and endl. That's end line, not end one, okay? Endl. And those are 2 commands that are associated with iostream, okay? And I'll explain that later on. cmath, okay, this says it's required for sqrt or square root. You could probably guess that cmath is a family of math commands, okay? So in this program, we are going to be basically calculating the distance between 2 points, right? What happens once we've calculated that distance? Well, if you don't do anything with that result, then this program is useless, right? So what you have to do, right, at the very least, is you display the result. You display that distance, right, onto the screen. So the command to display something on the screen is included in iostream, okay? And then when you're calculating that square root, calculating the square root of a number is actually part of the cmath family of commands, okay? So these families of commands are what we refer to as libraries, okay? That's just a programming term, a computer science term, right? But get used to it because you'll hear this term over and over, okay? So we have an iostream library and a cmath library that we need to make use of in our program, right? And because we need to make use of the commands in these 2 libraries, we have to specify in our program that we need these libraries to be part of our program, okay? And the way we do that, okay, is with this include command. So you put that hashtag, if you will, you put hashtag and the word include, and then within these angle brackets, okay, you put in the name of the library that you want. So there are a few different libraries, as I mentioned, okay? And you might ask, well, how do I know which libraries are available, right? And which ones I need? And it's pretty simple, okay? If you have the textbook, remember, it's not required, but if you have the textbook in the appendix, okay, it lists every single library and it lists every single command that's in each of those libraries. So if you don't know which libraries you need, you basically look it up in a list like that. Where else can you find these lists? Well, you Google it, right? Google built-in C++ libraries, or something like that, okay? And you'll be able to find a whole list, right? A list of all the libraries and all the commands, all the functions that are in each one of these libraries, okay? So this is how you include libraries and how you put libraries into your program, okay? So let me say something about these two libraries in particular. If you think about it, right, every single program that you write, it's going to generate some result, right? And you're going to display that result on the screen, because when you run your programs for me, I've got to see the result of your program. So are you going to need the IOStream library in every single program you write in this class? Yes. And the second library, CMath, right? That has a bunch of math functions. It'll do square roots, it'll raise numbers to powers, it will do trigonometry, right? It will do exponentials. It does things like that. So how often are you going to use those in this class? Well, this is a engineering programming class, right? So you're going to be writing programs where you're mostly dealing with numbers. You're going to be doing quite a bit of math. So you could probably imagine that CMath is going to be needed in most of the programs that you write, okay? So these are definitely two major libraries that you'll be using, okay? And then there will be more, a couple more, and we'll mention those, all right? Now, related to this topic, right? The programs that you write in this class are going to be fairly short, right? They're not going to be memory intensive, right? They're not going to be so large that your computer just completely slows down. So does it make a difference if you include a library that you do not need in the programs that you write? Right? And the answer to that is no, you're not going to see a difference, okay? So, I mean, if you feel like there's a library that you might need to make use of, right, just go ahead and include it. It doesn't matter if you never use it, okay? It's taking up some resources, but you won't notice it, right? Because the programs you write are so small and computers are so powerful these days, a computer doesn't even notice, okay? So let's move on. The lines that come after this, okay, is this line, using namespace standard, okay? So every time you include one of those built-in libraries, you are going to put this line, okay, after those include statements. Okay? And I don't want to get too much into the detail of this, right? But all this is really saying is those libraries that I've just included are stored in a standard location. Okay? That's basically all it is. Because there are rules, right? When Microsoft writes a C++ programming tool, they have to follow certain standards, certain international standards, and one of those standards says, put all your built-in libraries in this location. There's a specified location, right? Meaning a folder within your C++ directory where those built-in libraries have to be placed. And this line just says, okay, you could go ahead and find those libraries in the standard location. Okay, so you're going to have this line pretty much in every single program that you write. All right. Now, I did say something about Microsoft, right? And we'll get more into that in the second half of this lecture, okay? We're going to be using the Microsoft product to write our programs, okay? And that product, by the way, is what's usually called a compiler, okay? Let me write that down for you. COMPILER, okay? So when you compile a program, right, what you're doing is you are taking the C++ code that you write and you're converting it into a form that your computer can understand, and you're making it into a program that your computer can run, right? So that's what compiling means. It means you're interpreting or translating, right, your program into a form that the computer can understand. If you think back to what we mentioned last time, right? When we talked about the different types of programming languages, we said there was a machine language or low-level language, right? Then there was assembly language, and then there was a high-level language, of which C++ is. If you remember that part of the lecture from last time, high-level language is very similar to English, right? So it's something that we find easy to understand. It's something the computer absolutely cannot understand, right? What the computer understands is machine language. So when you write something in C++ or in some high-level language, okay, you cannot just give it to your computer and have the computer understand it. What has to happen is it has to be converted into machine language, okay? And that's what a compiler does, okay? A compiler will take your high-level code and then convert it into a bunch of zeros and ones, right, into machine language that a computer can understand. All right, so just wanted to mention that so people will know what I'm referring to every time I say compile or I refer to a compiler. All right, so next line. Int main with empty parentheses, okay? So I do not want to go into detail with this yet, okay? Because we will get into that in probably 2 lectures time, 2 or 3 lectures time, all right? But needless to say for now, okay, once you get done with all the preliminary stuff, meaning your initial comments, your includes, and that using namespace standard, once you get through all of that, every single program you write, okay, will start with something like this, okay? In fact, you could always use this. Just start every one of your programs, right, with this. And int main basically indicates that this is now the main part of your program, okay? This is really the start of your program. All the stuff above it, those are preliminaries, right? That's like making sure everything is in order before you actually start getting into what the program is going to be doing, okay? So int main is the start of your program, okay? And we'll talk later about what int stands for, right? And then main is part of the rules of C++, okay? C++ has a lot of rules, okay? And, you know, rules are basically that, right? It's whoever invented C++ decided to come up with a bunch of rules, and they said, you must follow these rules, okay? Some of them make sense. Some of them we kind of look at and they seem questionable, right? You look at some of the rules within C++ and you just say, what the heck were the inventors thinking when they came up with these rules, right? But, you know, that's just the way it is, okay? C++ is by no means perfect, but you know, it's powerful. It can do a lot. And the funny thing is, C++ might be losing some of its popularity, right? Because there are newer and newer languages. But a lot of these newer languages are based on C++. They're just improvements on C++. Okay, so C++ is definitely a good foundation language to learn because once you learn C++, right, and you move to Java or C# or Python, you're going to see a lot of similarities, right? And that's what's good, right? Because it's a good foundation. All right, so int main, for now, let's just say that this is something that you will always have in your program, okay? And we'll get back to that in a few lectures time. All right. Now, what happens after int main? We have a starting or an opening brace, okay? So that is very important, okay? Remember what I just said. I just said that int main basically indicates that this is the start of the actual program, right? Everything before int main is preliminary. But the actual program itself, meaning where all the calculations are actually going to take place, right? Where the results are going to be displayed, everything else comes after int main, okay? And the next rule of C++ basically is that your main program, okay, the main part of your program itself must be enclosed within braces. So right after int main, we put an opening brace, okay? And then at the very end of your program, we put a closing brace, okay? And let me kind of show you exactly what I mean by that. Let's scroll back to that program, right? The full picture of the program. You can see right after int main, there is the opening brace, right? And then everything that's after that is the program itself. Those are all the calculations that are done, right? And then if we go to the next page, right, the program continues, it ends, and then you'll see the closing brace right here, right? That indicates that it's the end of the program. Now, what is that line after the closing brace? Think about that for a second, okay? If you said that it's a comment, then you are absolutely right. Can you make out the slash asterisk, which indicates that it's a comment, right? And I put in a bunch of dashes, then there's the asterisk slash to indicate the end of the comment. And the reason I did that, I mean, just for aesthetics, right? I just wanted to put a line to indicate that that's the very end of the program, okay? And the way you can do that, of course, is through a comment, okay? So that line actually is not necessary. All right, so let's continue on. Let me scroll back. Okay, so those braces are very important, right? Every single rule that I'm pointing out, okay, must be followed, okay? Otherwise, you will run into syntax errors and your programs won't run, okay? Again, it bears repeating, right? It makes sense to repeat again that C++ has a lot of rules. Some of them don't make too much sense. Some of them you're going to think are a little tedious, but you must follow them, okay? If you go ahead and invent your own language, then you could come up with your own rules, right? And anybody that wants to use your language has to follow your rules. So that's how it works. All right, so what comes next, okay? The next two lines, as shown in this blue box, right, are the word double, and then followed by what I'm going to call variables, okay? So this is very important. This is probably one of the most important things in this whole program, okay? You see x1 parentheses with the number 1 inside, y1 the value 5, x2 the value 4, y2 the value 7, side 1, side 2, and distance. I'm sure that you all know exactly what these are referring to, right? Because, I mean, we discuss how we're going to calculate the distance between the 2 points, right? So x1, y1, those are the coordinates of the first point. x2, y2 are the coordinates of the second point. Side 1 is the difference in either the x or the y coordinates, right? Side 2 is also the distance in the x or y coordinates. And then distance is that square root calculation, okay? So why is this necessary in the computer program, right? In our program. And what does the word double mean? So there's some background here, okay, that I must talk about. So computers, we said, have memory, right? And memory basically is a bunch of on-off switches, and basically the memory, what we store in those on-off switches are zeros or ones. 0, right, which means the switch is off. 1 meaning that the switch is on. But a computer has billions, right? These days, it's got billions of these on-off switches, okay? So how does it know exactly which switches to use for what? Like if I tell a computer, store the number 5, right, in memory, how does it know where to store that number 5? First of all, it has to convert 5 to a binary, right? So you can have some zeros and ones, but then where does it store those zeros and ones, okay? And a lot of times, I mean, these days, of course, computer engineers have all that figured out, right? There's like there's a command center, if you will, right, in every single computer, and that handles all the traffic, right? It kind of chooses the correct location to store certain values, and it's got all these capability, right? Everything's taken care of for you, right? But you still have to help it do its work, okay? And what that means is this, okay? Every time you want to store some data in your computer's memory, you have to tell your computer, right? You have to tell the program exactly what kind of data you're going to be storing, okay? You have to tell it if it's going to be a number, right? If it's going to be maybe a letter or a symbol, if it's going to be a word, if it's going to be a sentence, right? But you have to tell your computer exactly what you're storing in memory. Now, when it comes to numbers, right, and that's what we're mostly concerned about, is numbers. When it comes to storing numbers, right, if you remember last time when we were talking about number conversions, your computer deals with both whole numbers and fractional numbers, right, or numbers that have a fractional part to them. Okay, so whole numbers are what we refer to as integers. So if you're dealing with only whole numbers, you have to tell your computer that, okay? Tell your computer that, okay, this data that I'm storing is an integer, right? If you're going to store something that has a fractional part, right, what we call a real number, if you remember from algebra, right? If you're working with real numbers, then you've got to tell your computer that, okay? So that's the word double. Okay, that's what the word double is referring to. Okay, double is computer science speak. It stands for double precision, right? And double precision is computer science speak for a real number, or a number that has a whole number portion and a fractional portion, right, or a decimal portion. Okay, if you're only working with whole numbers, then you use integer or int, okay? But basically, you have to tell your computer that, all right? And there's another important rule here, okay, in programming, and it's that every single data that you're going to be working with, every little piece of data, okay, has to be given a name, okay? And the name is what we refer to as a variable, right? A variable, if you remember from algebra again, is just giving a name to some value, right? And then variable means that that value can change, right? If so, I could create a variable x, right? And then x could take on any value. I could change the value of x, right? So when you start writing a program, okay, here's what you will need to do. You have to think ahead, okay? You start thinking through exactly what your program is going to be doing, and then you have to start making a list for yourself of all the different values, all the different data that you're going to be working with, okay? So in this program, right, you're going to think to yourself, I'm going to write a program that calculates the distance between 2 points. So right off the bat, right, 2 points in 2D space. I need x and y coordinates for each point. So that's 4 values. I need to come up with 4 variables or 4 names for those 4 values. And that's x1, y1, x2, and y2 as listed here. Okay? And then you keep thinking, right? You say, well, I am going to use Pythagorean's theorem. I'm going to create a right triangle out of this. So a right triangle has 2 sides, right? And that means I'm going to call those a right triangle, has 2 perpendicular sides, right? I am going to call those side 1 and side 2. And then the result is going to be my hypotenuse, right, which I'm going to call distance. And those are all the different values that we're going to be working with in this program, right? So once you make that determination and you've come up with this list, then you put it into code. And here's how you put it into code, right? You think, I want this program to be as general as possible. I don't want my x and y coordinates to only be integers, right? I want them to be able to be real numbers as well, okay? And if x and y are real numbers, then side 1 and side 2 obviously have to be real numbers, okay? And distance, of course, must be a real number, because even if x and y, my x and y values are integers, can everybody see that once you take a square root, right, that distance could be, usually is going to be a real number, okay? So once you determine that every single value that you're going to be working with is a real number, then you're going to say, okay, every single one of these is going to be of this type double, okay? So now this is what we call a type, okay? A number type or a data type, okay? So a numerical data type can be either an integer or a double, okay? And this is what we call declaring our variables. You have to declare, meaning define all your variables, okay? So this might seem like a complicated thing to do, right? But this is something that's required. This is something you get used to very quickly, okay? Remember I keep saying that a computer must be told exactly what to do step by step, right? And this is part of that, right? If you were doing this by hand, you would not even create these variable names, right? You're going to say, okay, I've got these coordinates. I'm just going to do some calculations, take the square root, and there's my result. But if you were asking a computer to do this, every single number must be given a name, and then it must be told step by step exactly what's going to happen. Okay? So we're going to declare our variables. Now, there are some other important things here that I need to mention, okay? First of all, you see that the word double is used only once, right? I put the word double, and then I just start listing a bunch of variables, and that is perfectly fine, okay? C++ does have some nice shortcuts, okay? And this is one of them. Rather than forcing you to say double x1, double y1, double x2, double y2, and so on. Right? C++ says if all these variables are of the same type, right? If these are all doubles, then all you need to do is put the word double once, and then you just list all your variables of that type after the word double. Okay? Can you still do double x1, double y1, double x2, double y2? Yeah, right? Of course, that will still work. But you know, if you have a shortcut like this, then you definitely want to go ahead and use it. All right. Now, you can see the other thing here that I want to point out is notice that all your variables are separated by a comma. Okay, so that's important. You need to separate them by commas. And then at the very end, notice the semicolon. Okay, the semicolon is one of the most important things in C++. One of the most important punctuation rules in C++. Okay? C++ says at the end of most commands, okay, there are going to be exceptions, but at the end of most commands, you put a semicolon to tell your computer that that's the end of that command. Okay? And what that means is it doesn't matter if your command runs several lines long. Okay, it could be one line, it could be several lines. C++ just keeps going until it encounters the semicolon. Then it knows it's the end of that command. Okay, and if you recall, I said just a few seconds ago that there are exceptions, right? So let's scroll back to the beginning of this program again. Notice the include IOStream and include CMath. They don't have semicolons. That's an exception. Okay? Your includes do not have semicolons. Using namespace standard does have a semicolon. Okay? Int main does not have a semicolon. All right? And then your double, my declaration, we just said has the semicolon. Okay? So here's how C++ really treats this, right? It says it encounters this command, double x1, y1, x2, y2, right? And it just keeps going, right? And treating everything that comes after that as the same command until it encounters the semicolon. So theoretically, right, you could write a C++ program that's one super long line. Okay? It doesn't have to be multiple lines, because all you do is you just keep putting semicolons. Okay? And you never hit the return key. So conceivably, you could do that. Right? Is it a good idea to do something like that? No, right? Of course not. That makes it very difficult to read. Right? So what we like to do is we like to start a new command on a new line. Good? All right, so hopefully that made sense. Let's go on to the next line. Okay, side 1 is equal to x2 minus x1. Side 2 equals y2 minus y1. I think these are pretty obvious, right? And then the distance is equal to square root side 1 times side 1 plus side 2 times side 2. All right, so side 1 is equal to x2 minus x1, and side 2 is equal to y2 minus y1. Even though these are very obvious commands, there's still a few things I need to point out here, okay? All right, so the first thing is you notice that this is written side 1 on the left-hand side, side 2 on the left-hand side, right? And then the subtraction on the right-hand side. And that is necessary, okay, in C++. Okay? In C++, every time you write an equation, right, you equate one thing to another, the left-hand side must contain just one variable. Okay? So you would not be able to write this first line here as x2 minus x1 is equal to side 1. If you do that, you'll get an error message. Okay? Your computer will tell you that the program can't run because there's an error. That will be a syntax error. Okay? So just keep that in mind. Right? Anytime you write an equation, you must have just one variable on the left-hand side. All right? And that distance calculation, okay, we get to, this is where that SQRT, or square root, comes in. Okay? So that command, SQRT, is available because we included that CMath library. Okay? So square root is actually part of the CMath library. Right? And since we included it, now we can make use of it. Now, how do I know how to use this square root command? Right? Well, remember I said you could always Google, right, every single library that exists in C++ and look up what all the commands are. So if you looked up CMath, right, and then found square root within that CMath library, usually, right, if you Google it, you should be able to come up with basically some details on how you use it, okay? And so you basically have to read or do some research, right? Now, if it's something that you use over and over, then obviously it becomes second nature, right? So just for the purposes of this program, let me just quickly discuss square root, right, and how you use it. The square root command basically says you write the word SQRT, okay? Then inside the parentheses, okay, you could either put a number or you could put something that equates to a number, that results in a number. And then it'll just take the square root of that number, okay? So in our case, right, what we want is the square root of side 1 squared plus side 2 squared. And so that's exactly what we put, right? Side 1 times side 1, of course, is side 1 squared. And you add side 2 times side 2, or side 2 squared, right? And that, everything inside the parentheses obviously results in a number. So you can take the square root of that number. Okay? Now, why do we do side 1 times side 1? Because C++, okay, does not make use of the caret. Right? I know some of you probably have used like Excel, or you might have used some other programming language where you're allowed to square something by simply doing this. Okay, let me show you. Where you could do just side 1, then you do a caret, right? And then you put the 2 for square. Okay, C++ doesn't allow that. It doesn't recognize that. Okay, so if you're going to do a square, you do side 1 times side 1, and then side 2 times side 2. Now, that's obviously not the only way of doing it, right? Because imagine you're trying to do side 1 to the 10th power. You don't want to do side 1 times side 1 times side 1 all the way until you have 10 side 1s, right? So within the C math library, there's actually another function or another command called the power command, okay? And the power command works like this. It's the word POW for power, okay? Then in parentheses, then the value that you want to raise to a power. In our case, it's side 1. Then you do a comma, and then the power you want to raise to. Okay? In our case, for square, it's 2. Okay? And the nice thing about this command is for your power, it doesn't have to be a whole number. Okay? It could be a fraction. It could be like 0.1 or 0.2. And it could be negative. Okay, so that's a very nice function to have available. Okay, so that's how we're going to calculate that. Let me talk about one more thing here with this square root. Okay, programming is kind of an individual thing, right? If I give you an assignment to write a program to do something, every single one of you, right, is going to come up with your own way of doing it. Okay, I probably will not get 2 identical programs. I should not, right? Not unless you're copying off of each other. Okay? And the reason for that is there's always more than one way of doing something. Okay, in C++ and in any programming language, right? So this is just one way of calculating the distance between 2 sides, okay? And this is one way of writing the program. Now, some of you, okay, might come up with your own way of doing this that's going to be maybe a little more efficient, meaning it might be fewer lines of C++ code. Okay, and that would be perfectly fine, right? So here's one way of doing it. And I'm not saying that one way is better than the other, right? But another way of doing this is, remember I told you, think ahead and plan ahead and try to come up with all the different values that you're going to be working with, right? And then you make a list of all your variables. So another way of thinking about this, right, is you might not even think of side 1 and side 2 as a variable. You're going to say, my distance, right, it's going to come from the distance formula, right? Some of you might remember that from algebra or geometry. There's something called a distance formula, and that distance formula, of course, is based on Pythagorean's theorem, right? But if you use the distance formula, it doesn't say anything about side 1 and side 2. It goes immediately to distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared, right? That's the distance formula. So if you go ahead and use that, do you ever need to come up with these 2 variables for side 1 and side 2? Right? And the answer is no. Okay, so that would be perfectly fine. In that case, how would you write the C++ code for that distance equation? All right, so let's write it. It will be distance is equal to SQRT, okay, of, let's say we wanted to use the power function, right? It would be power x1 minus x2, comma 2. So that says take x1 minus x2, raise it to the 2nd power, right? Then plus power y1 minus y2, comma 2, right? And make sure your parentheses match up, okay? And then put a semicolon at the end. Remember, right? Remember the need to use the semicolons. All right, so this is an alternative. Okay, so let's go back to this. All right, and we're nearing the very end of this program. Okay, so we've now gone ahead and calculated our distance. Right, and everything seems fine up to here, but if I just left the program right here, like we said earlier, it would be useless, right? Because we haven't displayed the result. So how do we display the result? All right, so let's take a look. Here is the command. Okay, this line. Now this is going to seem a little different, right? So we'll talk about that. So cout, okay, is a command that's inside that IO stream library. And it's the command for displaying something to the screen, okay? And what you can see is that you could probably tell that this is going to display some message that says the distance between the 2 points is, right? And it should give the numerical value for that distance or that square root, okay? And that should be it, okay? So we'll get more into what this command is and how it works. Okay, in just a little bit. All right. And then the very next line after that is the command return followed by the value 0 with a semicolon. Okay, and this basically indicates that it's the end of the program. Okay, again, we'll get more into this in a few lectures. Okay, but for now, just know that in every single program that you write, right, once you get to the very end, you're going to put return 0. You could actually put return followed by any number that you want, right? You could do return 1, return 2, whatever you want, okay? But 0 is the simplest, okay? And that indicates that it's the end of your program. All right, so that's our C++ program line by line, okay? And hopefully that gives you an idea of what's required, right? The level of thinking that's required, the level of planning, and then the amount of precision that's required. And by that, I mean you have to be sure that you follow every single rule that's prescribed in the C++ language, okay? All right, so a few more quick notes, okay? The first one is important. All commands in C++ are in lowercase, okay? And C++ is case sensitive. So if you try to write one of the commands in uppercase, right, you are going to get an error message, okay? That's a syntax error. That's a spelling error, okay? Now, when you come up with variable names, right, when you come up with names for your own values, then you are allowed to use uppercase. But it's case sensitive, right? So if when you refer to that variable again, you better make sure you use the correct case. Right? The other thing, I talked about blank lines, right? How the blank lines make your program easier to read. Well, you also notice that there are some indents throughout my program, right? You see, like the first few lines, these are all left justified, but then after the brace, everything is indented, right? And again, that makes it easier to read because then that makes it easy to pick out where the main program is. Right? Now, how do you go about planning for these indents? Right? The spacing, the line spacing, you really, that you have to take care of on your own, right? But as far as the indents go, let me say this. The program that you're going to be using, the Microsoft software that you'll be using, right, as a compiler, okay, is pretty smart, okay? It actually handles all the indents for you. So I always tell students, it knows better than you do how to format your program so that it's easy to read, okay? So it will do all the formatting for you and just accept what it gives you. Do not try to override its formatting, okay? There's no point. You're just wasting time if you try to do your own formatting, okay? So again, indents make things easier to read. Now, in the old days when software didn't indent for you, right, you had to worry about it, right? If you try to make a program easy to read, you put in your own indents and all of that. But today, I mean, you know, the software handles that for you. Okay, so let me not talk anymore about that. Okay, and so let's get into a little more detail, right, about variables and all of that. So if you go back to this command, right, where we declared our variables for x1, y1, and so on, okay? Another thing that I should have pointed out here, okay, and let's talk about it now, is the parentheses with the numbers, okay? So anytime you declare a variable or you create a variable, right, what you're allowed to do is you're allowed to immediately give it a value. This is what we call giving it an initial value, okay? So what we're doing in this program is we are creating the variable x1 and immediately giving it a value of 1. Okay? Then we are creating the variable y1, giving it a value of 5, right, and so on. Now, is that necessary, right? And it's not. Okay, what we could have done is just left out the parentheses, right? I could have just left all this out. I could have left all that out, right? And then right after that command, I could have set the values for x1, y1, x2, and y2, right? And the way I would have done that is I would have said x1 equals 1, semicolon, right? y1 equals 5, semicolon, and so on. Okay, so that's how you, that's basically writing an equation, is it not? Right? It's a very simple equation, right? But it's an equation nonetheless. And notice I followed that rule where I have a variable on the left-hand side, right? And the right-hand side, obviously, it could be some value or anything that results in a value. Okay? So that's one more thing about these variables. Okay. Now, I'm going to talk quickly about this. We're not going to use this very often, right? You could use it if you like, right? If you think it's necessary. But for most of what we're going to be doing, this is not necessary, okay? But the next thing here is if you ever deal with a value in your program that's a constant, something like pi, right? 3.1415, and or something like acceleration due to gravity, as I have there. You know, those are not really variables, right? Those values never change. Okay? You still have to give it a name, right? It's still treated as a variable because it is a number, and like we said in computer programming, you have to give all your numbers names, right? Declare them as variables. Now, so what we do, right, is to prevent the value of pi from being mistakenly changed, okay? You could put the word const, constant, before you define pi as a double, okay? And what happens if you do that is that tells the computer that the value of pi should never change, right? So if later on in your program you try to change the value of pi, you will get an error message, okay? So that just kind of puts in a safeguard, okay, to someone trying to change the value of a constant, okay? Like I said, this is not really necessary, right? If you feel that you need to do something like this, go ahead and do it, right? But it's not critical. All right, so now let's get a little more into numbers, okay? The different types of numbers that we can work with in C++. Okay, I had told you that there were integers and real numbers or double precision values, right? But historically, there's actually more than that. Okay, and you know, you might think, you might ask, really, why there's a need to make a to differentiate between integers and real numbers, right? Because integers, are they not just a special case of a real number? Yeah, right? It's a real number where you have a whole number portion and the fractional portion is 0. So that actually is correct, and you could actually program with that thinking, right? Meaning just treat all your numbers as real numbers, as doubles, right? Even if you're going to be working with integers. And that would be fine, right? But historically, okay, when computer programming was first being developed, in the early days of computing, it was very important that you made a differentiation between whole numbers and fractional numbers. Okay? And the reason is this. In the early days, computers didn't have a lot of memory to work with, right? So every little bit of memory that you can save, right, was important. And it should be fairly obvious that you don't need as much memory to store an integer as you do to store a real number, right? Because a real number not just has the digits for the real number portion, for the whole number portion, but it's got to store the digits for the decimal portion or the fractional portion, right? So a real number requires a lot more memory, okay? So that's why historically in computer programming, you were always forced to tell the computer whether the number you're working with is an integer or a real number, okay? And that's kind of stuck, right? So these days, everybody still kind of sticks to it. And there are actually situations where you have to make sure you either use an integer or a real number, right? And we'll talk about those next time, right? So anyway, the way integers and real numbers are stored in your computer, okay, goes something like this, okay? And this could change according to the operating system you're using, right? Like for instance, it's different between a Mac and a PC, right? And let me just give you this list, right? Let's skip right to this list. This is the only thing that's important here, okay? But this is basically a summary of all the different types of numbers that a computer can store, right? And this is based on the PC, okay? So it might be a little different on the Mac, but this is representative, if you will, okay? So in the very early days of computer programming, okay, people actually created two different types of integers, okay? There was something called a short integer and something called a long integer, okay? And it just basically differed in how many on-off switches, if you will, right? How many bits were allocated to the number. So if you declared something as a short integer, then the computer set aside 16 bits to store your number, right? So that's 16 on-off switches. And if you think about that, right, what is the largest number you could store with 16 bits? It's 16 ones, right? 16 binary ones. Now, your computer has to be able to differentiate between positive and negative numbers, right? So the way most computers work is, out of those 16 bits, right, the first bit is used to specify whether your number is positive or negative, okay? And then that leaves you with 15 bits, right? So the largest number you could store is 15 ones, right, in binary. If you go through that conversion, meaning, remember how you take each digit multiplied by 2 to some power, right? If you do that, what you end up with is 32,767, okay? So a short integer can store values between negative 32,767 and positive 32,767, okay? And the way you would declare it is you use the word short, right? So this is of type short, and then you give it a variable name. So you could do something like short x, right? And then x could have a value between positive and negative 32,767, okay? And then there was also something called a long integer, which just meant you had 32 bits, right? So again, the first bit is used to specify positive or negative, leaving you with 31 bits. If you do conversion from 31 ones binary to base 10, you get that, 2,147,000,000, you know, the rest of that number, okay? So that's a long integer. Now, these days, right, we have so much memory in our computers that the difference between short and long integers, you know, doesn't make a very big difference, okay? So even though you can still use short integers, most people don't even bother, okay? They just use int or long, right? Even today, I mean, since people don't use short very often, they also stopped using long. You just, every time you have an integer, you just use int, okay? So that's what we're going to stick with, okay? For the most part, just use int if it's an integer. Now, in the old days also, okay, for real numbers, there was also a differentiation between a short real number and a long real number, okay? A short real number was called a float, or a floating point number. It had 32 bits, okay? And if you look on the right column of this table, it says 6 digits of precision. That means there are 6 bits used to store the decimal portion, okay? And then you have 1 bit, of course, to store whether it's positive or negative, and then that still leaves you with quite a few bits to store the whole number portion, okay? But here's the great thing about real numbers in computing, okay? If necessary, your computer automatically stores the number as scientific notation. So in the float data type, okay, you actually have 1 digit for positive or negative, you have a few digits for the whole number portion, then you have 6 digits for the decimal portion, and then there's actually a few more digits to store the power, that 10 to the some power, right, in scientific notation. There's also space to store that, okay? So based on that, okay, you can see that the range of numbers that you can store is listed as what you have there. So you can store pretty large or pretty small numbers, okay, with a short real number. But again, these days we have so much memory in our computers, nobody really uses the float data type, okay? What people use is the double, okay? You could call it a long double in C++, but there's no need, okay? You just call it double. That means you have 64 bits. Okay, and then you can see the range of values that you can store. It's much larger, right? Negative 308 power, right? 10 to the negative 308 power to 10 to the positive 308 power. That's large enough for pretty much anything you're going to be working with. Okay, so bottom line, in the programs that you write, okay, you're going to be using integers, int, or you're going to be using double, right, for your for all the numbers that you're working with. All right, so that is it as far as numbers and variables in C++. Okay, let's move on. There are other data types, okay, that are available in C++. We're not going to use these too often, right? But just so you're aware of them, there's something called a Boolean data type. A Boolean data type, okay, can have 2 values, either false or true. Okay, and the way you declare something as Boolean is you use the word bool, right? And then you give a variable name, and then you can set that variable equal to the word true or the word false. Okay, so anytime you have something that could have just 2 states, okay, then you could declare that as a Boolean. Do you need to use Booleans? Are Booleans necessary? The answer is no, right? You can imagine, just use integer, right? And then just assign a value of 0 or a value of 1, okay? That works just as well as a Boolean. So why does the Boolean exist? Well, if you think about it, right, how much memory do you need for a Boolean? Think about that. Right? You need 1 bit for a Boolean variable. That's why they exist, right? In the old days, when computers have very little memory, okay? You could use basically 1 bit for a Boolean as compared to 16 bits, right, for a short integer, okay? The next data type I want you to be aware of is a character, right? So a character is any symbol that you could type in from a keyboard, right? It could be all the numerical digits, 0 through 9. It could be all your letters, upper and lowercase, A through Z, right? And it could be all your punctuation symbols, exclamations, commas, semicolons, colons, so on and so forth, okay? So how do you declare something as a character, right? It's CHAR. Some people like to use the word char, right? Some people call it char. So char, and then you give a name, right? And then the way you assign a value is you have to put the character in single quotes, okay? So when you declare character ch1 and you want to set it equal to 3, you put 3 in single quotes, because you're not referring to the number 3, you're referring to the symbol 3, okay? Make sure you understand the difference, okay? The number 3, right, is something that you could do math with. The character 3 is just a symbol, right? Now, how does the character 3 get stored in your computer? You know how the number 3 gets stored in your computer, right? In your computer's memory. It's stored as 1, 1, right? That's binary for 3. But the symbol 3, it's not stored as 1, 1, okay? Here's how symbols work, okay, on the computer. Remember, the computer can only store zeros and ones, right? So there is something called an ASCII character set, right? A lot of you probably have heard of this before. And the ASCII character set, okay, is basically just a standard that people have come up with. And all it does is it takes every single symbol, okay? It takes every single symbol that's available and it assigns it a binary number. It actually uses a 7-digit binary number, okay? And then, so for instance, right, this can be found online, so I just pulled this up in Wikipedia, right? So for instance, let's look at the symbol for exclamation point, okay? That's right here. The exclamation point symbol is stored in your computer's memory as 0100001. Okay? So if you declare something, some variable as a character, right, and then you set that variable equal to the exclamation symbol, that binary number is what's stored in your computer's memory. Okay? Now, how does the computer then know that that's actually referring to the exclamation symbol? Well, you declared it as a character, right? So if the computer knows that this is actually referring to a character, then it knows that it's not referring to the number, right? And what that means is when the computer engineers design the computer, they have to put this list into the computer somehow. This list is stored somewhere in the computer, okay? So when the computer goes to display some character, it basically looks at that binary number that's in memory. It goes back to the key, to this key, right? And it matches that binary number with the exclamation symbol, and it displays the exclamation symbol on your screen. Okay, so that's how that works. All right, so characters are just that, okay? They're just symbols. Okay. Let's move on. Operators, okay, when you work with math and equations. Okay, and let me just give you there's something called an assignment operator. That's the equal sign, right? If I have a variable and I want to set a value equal to it, it's just like shown in this first blue box, okay? You do x1 equals 500. Okay, so the equal sign is what we call the assignment operator. If you have a bunch of variables that are all equal to the same value, C++ actually lets you do this, as shown on the bottom here. Okay, so you don't need to write multiple lines that say W equal to 0, X equal to 0, Y equal to 0, Z equal to 0. You just set all of them equal to each other and then equal to 0. Okay, that's a shortcut in C++. That's not available in every language. Okay. Now, how about when you start doing arithmetic, right? The symbols that you have available to you are, as you would expect, okay? Addition, subtraction, multiplication, and division, right, are the plus symbol, the minus symbol, the asterisk for multiplication, and the slash for division, okay? Then there is one more operator in C++ that's very important. It's what we call the modulus operator, okay? And it's the exclamation symbol. So the modulus symbol, okay, will only work between two integers. So this is one situation where you must declare something as an integer, okay, in order for this to work, okay? So here's how the modulus works. It takes the division between two numbers and returns the remainder, okay? So my examples on the bottom here, right, should illustrate how this works. 2 divided by 7, right, if you were to do that, 2 modulus 7 means you take 2 divided by 7, right, you get 0 with the remainder of 2. So the result of that operation is 2. If you do 11 modulus 2, okay, that means you take 11, divide by 2. What you end up with is 5 with the remainder of 1. Right? You forget about the 5 and you just return that 1. Okay? So the modulus operator actually is very important in a lot of the programs you're going to write. Okay? And let's talk a little bit about two uses of the modulus operator. One use is, you might imagine, trying to do a conversion from base 10 to base 2. Right? Remember how that worked? When you're doing a conversion between base 10 and base 2, you just kept dividing, right, by 2, and you keep noting down the remainders. So the modulus operator can be used to do that. Right? If you were to write a program where you wanted to display what the base 2 or the binary equivalent of a base 10 or decimal number was, you could use the modulus operator. Right? The other use of it, okay, is to determine whether a number is divisible by another number. Excuse me. So, for instance, if I wanted to check whether 12 is divisible by 4, then I want to check whether 12 modulus 4 is equal to 0 or not. Right? I ask myself, is the modulus of 12 and 4 equal to 0? If it is, what does that mean? It means I could divide 12 by 4 and get a remainder of 0. Right? And if I have a remainder of 0, then that means 12 is divisible by 4. Okay? So that's another way of using the modulus operator. Okay? And a special case of this would be if you're checking whether a number is odd or even. Okay? If I want to check whether a number is even, what do? I take the modulus with 2, and if it's equal to 0, I have an even number, right? If I take a number and it's modulus with 2 and I get 1, then I have an odd number. Okay, so keep that in mind because you're going to be making use of that later on. Okay? All right, so let's go on to the next slide. Okay. What if you're writing an equation where you have a mixture of operators, right? You're doing addition and subtraction, multiplication, division. Long story short, the same order of operations that you learned in in algebra applies. Okay, so anything that's in parentheses, you do first, right? Followed by addition, followed by multiplication and division, and in this case, also by modulus, okay? And then followed by addition, subtraction, okay? Now, what if you don't want to deal with that order of operations, trying to remember that? Then what I would suggest is just put in as many parentheses, okay, as you think is necessary to make things easier to read, okay? And note, keep in mind that you can only use parentheses, okay? You can't use brackets and braces or anything else, okay? C++ allows only parentheses in math equations. All right, so let me give you an example of that. If I wanted to, if I wrote something like, x, maybe x is equal to a plus b times 3 minus d divided by 2, right? That is very different from if I did that. Right? Right? So put in parentheses whenever you think you need to. Okay? Yeah, so I shouldn't need to get too much more into detail with that. Okay? All right, so those are your order of operations. Okay, let's move on. C++, okay, and this is a very nice shortcut, okay, allows you to do something like this, okay. In a lot of programs that you write, okay, what you're going to do is something as shown in this blue box here, okay. You set up some variable, and then you say that that variable is equal to its current value plus 1. Or equal to its current value minus 1. Okay, and we'll talk more about why you would do something like this in the next few lectures, right? But if you were to do something like this, okay, C++ just lets you write that in a much shorter form as that variable plus plus, right, for the top case, or the variable minus minus for the bottom case. Okay, so nice little shortcuts to keep in mind, right? We'll get more into that, as I said, later on. Okay. All right, let me skip this. This is more of the same thing. Okay. Skip that. All right, so let me see, is this important? Yeah, so just a quick note about this, okay? When you declare things as integers and doubles, right? Keep in mind the number of bits that you have available to you, right? So remember, your integer, right, has 32 bits, right? And your real number has 62 bits, but it's also in scientific notation. So you could store much larger values, right, as real numbers than you can as integers. Okay? So for instance, if you declare integer, let's say integer x and y and z, right? And then you said x is equal to, let's say, 50,000, y is equal to, not 50,000, I'm sorry, let me, maybe 10,000, okay? So x is 10,000, and y is 20,000, and then you try to say z is equal to x times y, you're going to run into a problem, right? So why is that? Well, you know an integer, if you look back to that table, an integer could store values between, right, let me bring that up for you. Okay, an integer can store values between 147 million, and so on, right? And your double can store something much larger, right? So about 2 billion. So actually, let me do this. This is, so maybe x is, let's say x is, 10 million, right? And y is, let me see, y is 1 billion, right? So both x and y are within the limit. Both, right, they're less than the largest number that can be stored as an integer, right? But if I set z equal to x times y, once I take x and y and I multiply them together, I'm going to be well over that 2 billion limit, right? And what that means is z cannot be an integer anymore, because you're going to get an error message, right? Z has a limit because it's an integer of 2 billion something, right? That value here, 2,147,483,647, right? So what you would get is an error message saying that there's an overflow. Okay, that's what they call it. Okay, so if you anticipate something like this, right, what do you have to do? You would have to make z probably a double, right? And now if z were a double and you do it's equal to x times y, then definitely you have enough space or enough size to store that value of z. Okay, so that's just something to keep in mind, right? And okay, so we have that. Let me see. Let's go back to my slides here. All right, so the last thing that we want to talk about, okay, in this lecture is that cout command, if you remember, okay, from our sample program. Remember when we wanted to display the result of the distance between 2 points, right? There was that cout command that was part of the IOStream library, okay? So we're going to go into how you may actually make use of the cout command, okay? Because it's important for a lot of what you're going to be doing in the programs that you write. Okay? So once you include the IOStream library, you have access to the cout command. And here's how you use cout. Okay, it's actually quite straightforward. Okay, you should have you shouldn't have any issues with using it. Okay, so cout. Okay, basically you write the word cout in lowercase letters, then you put 2 less than symbols. And here's the nice thing: you could have as many of these expressions, okay, as you want. So you could do cout less than some expression, then you do less than some expression. And you put in as many of those expressions as you want, right? All separated by the less than symbol. Now, what is an expression? An expression could be anything that you want to show exactly as you type it on the screen. So that would be, and you will put that in double quotes. Okay, so in our example here, right, we said cout, then less than, and then in double quotes you put the radius is, then you end the double quotes. What that means is that phrase, the radius is, shows up exactly as is on screen, okay? So anything that's in double quotes can be used as one of these expressions. The other thing that you could put as an expression is a number, or anything that's equivalent to a number, okay? So you could directly put like the number 10, right? And then that would show up on the screen. No need for quotes, okay? You could put the number 10. Or you could put a variable as long as that variable has a value, has a numerical value, right? So in our case, right, if radius is equal to a value of 10 and you use radius as one of your expressions, then the value 10 shows up on the screen, okay? And another thing you could put as an expression is the word ENDL, okay, for end line. ENDL, okay, not one, but L, ENDL, end line, okay. You could put that as the very last expression, and what that does is it's like hitting the return key, okay. It puts the cursor onto the next line. So now you're ready to start writing another sentence, okay. So that's how you make use of the cout command, okay. And again, it's used for displaying messages to the screen, okay. So if you go back to the program, the sample program that we had, okay, and look at the cout command, look what's going to happen here. We have cout, right, and then the distance between the 2 points is, notice that that's in double quotes, so that shows up exactly as is, right? Then you have less than again, and then the variable distance. Remember, the variable distance now has some value, right? It's the result of that square root. So the result of that square root shows up on the screen, and then you have less than end line, which just brings the cursor onto the next line, okay? And that will give you a nice little display, nice little message to display on the screen, right, to show the result. Okay, now you're going to ask probably how many decimal places is going to be displayed, correct, right? How many decimal places for that distance? Because that distance is a square root, right? So it's going to definitely have a fraction part, a fractional part, right? And you have no idea how many decimal places it's going to get displayed. Now, if you don't really do anything about it, okay, the computer determines for you how many decimal places it wants to display, and that's a lot of times it's based on the operating system, right? The operating system might decide, like, I'll always display 4 decimal places, okay? Now, here's the good news, right? You can control how many decimal places get displayed. All right, so I am now going to show you exactly how you do that. Okay. There are 2 ways of setting how many decimal places to display. Okay. One way, okay, well, regardless of which way you choose, okay, let's just say this. In order to control the number of decimal places, you need to include an additional library, okay? The library you're going to want to include, okay, so at the top of your program, you would put in include, right? And then you put in here IO manip. Okay, that stands for IO, okay, if you don't know, stands for input output. Okay, input is anytime you're entering data into the computer, and output, of course, is anytime you're displaying some result to the screen. Okay, so input output, and then manip stands for manipulation. Right, so if you manipulate your input output, right, you're basically affecting how many decimal places, and you're affecting how your input or your output looks. All right, so you need that library if you want to change how many decimal places get displayed. All right, and then there are two ways of doing it. Okay, the first way, okay, is to use what's called a setf or set format command. Okay, and I'm not going to get into why these commands look the way they do. Okay, but needless to say, this is part of the rules of C++. Okay, you just have to follow exactly what you're told to use here. Okay, so what do you do? Okay, these are all the different commands that you could use with setf. Okay, so what you'll want to do is you will want to first fix, meaning you'll want to say that you want to fix the number of decimal points, right? And that's what this command that's shown here. So before you do any couts, okay, you first do this, cout, that's setf, right? Then in parentheses, you put ios : fixed, okay? And then there are other things you could do. You could play around with those. You could right justify, left justify, right? But for now, all we're interested in is setting the number of decimal places. Okay, so you set you want to fix the number of decimal places. Then you need one more command, right, to actually specify how many decimal places. And the way you do that, okay, is let's see, precision. Okay, so you do cout dot precision, and then in parentheses you specify the number of decimal places. Okay, so let's show you exactly how that works. So before you even display anything, okay, you want to do cout dot set f ios : fix. Okay, then you do cout dot precision. Precision basically indicates how many decimal places you want. Okay, and then let's say I want 5 decimal places. I will put 5 semicolon. Okay, so you need these two lines, and then you could go ahead with your cout, with your display. Okay. There is a disadvantage to this method, okay? And it's basically this. Once I specify that I want 5 decimal places, it doesn't matter how many numbers I print out after that. Every single number I print out after this is going to have 5 decimal places. If I want different decimal places for different numbers that I print out, that's going to be very difficult, right? So what I would need to do is I print out one number, and then I have to do a cout dot unset f that says unset everything I just did as far as formatting goes, right? And then I go ahead and do this again for the next number, right? Then I unset it and do it again for the next number, and so on and so forth. Okay, that is quite a pain if you're constantly changing the number of decimal places that you're displaying. Okay, so for that, there's a better choice. Okay, and that choice, okay, is going to be covered next. Okay. And this is slightly better, okay? Basically, if you look back at how cout works, right? You said I had said that cout could be used with a bunch of different expressions, and you could have as many expressions as you want. Well, in this next method, some of your expressions can actually be commands for formatting, okay? And these are the commands that you could have, right? So you want to do fixed, then you want to set precision, right? To set how many decimal places that you want to display. So here's how that would work. Let's say I want to display 2 values, okay? And I want to display them with different decimal places. I would do cout, okay? And then before I display the first value, I want to set its format. So if you remember, it was fixed right? That fixes the number of decimal places. And then I have to specify how many decimal places, right? So that was precision, or I believe it was set precision. Set precision, okay, I'm sorry. Let me erase that. Wrong tool. Set precision, right? And let's say for this first number, I want 3 decimal places, 3. And then I could go ahead and print that first number. So like I could say x equals, right, maybe x is equal to 5.21223. Now notice that I'm giving 5 decimal places, but since I set the precision to 3, this is going to display as 5.212, okay? And then I can go ahead and change my precision, set precision to, let's say, 4, right? And now I could say y equals, and maybe this is 3.1. Now, how is this going to get displayed? All right, if you say 3.1000, you will be correct, okay? And then finally, I just end it, end line with a semicolon. Okay, so that's how you change the number of decimal places. Okay, so notice that in this second method, it's much easier, right? Because it's much easier when you have different numbers and your different numbers have just different decimal places that you want to display, right? The first method is good if all your numbers are going to have the same number of decimal places. All right. So that is output. Okay, so get used to and get comfortable with these cout commands. Okay. The very last thing is input. Okay, so by input, okay, what we mean now is we want the user to type in data, right? So let's go back to our program. Right, remember we wrote this program that's going to calculate the distance between 2 points, okay? And the way we specify those 2 points, right, was we created our variables x1, y1, x2, y2, and then we immediately specified what our coordinates were, right? So the point x1 is has the coordinates 1 and 5, right? The point 2 has coordinates 4 and 7. There is a problem with this, okay, as a lot of you probably have thought of that. And that is that if I now want to calculate the distance between 2 other points, right, what I would have to do is go back into this program and replace those values, the 1, the 5, the 4, and the 7. Right? I have to replace those values with the new values, okay? And then I have to basically recompile, because once I change that program, change those values, it becomes a completely different program. So I've got to compile it again and then run it again to get a new result, okay? And, you know, that's not really the best way of doing it, right? It is, and, you know, it's fine if I only want to run this a couple of times, but if I want this to be something that's useful, right, that I could give to someone else to use, that I could use whenever I need to calculate this distance, then the best way would be to have someone type in the values every time I run the program, right? So ideally what's going to happen is you run this program, and then the program's going to ask you, what are your x values and what are your y values, right? You type those in, and then it gives you the result, okay? So how do we do that? Okay? The way we do that is through what we call an input, okay? And the input command, right, that's part of the IO stream library, is instead of cout is cin, okay? And cin is actually fairly simple to use, okay? If you look at cout, right? You follow cout. You use these less than symbols with cout. With cin, all you do is replace the less than with greater than, okay? But cin does work a little differently, okay? Cin is used with a bunch of what I call identifiers. Identifiers are basically variables, okay? So if you do cin, greater than x1, right? What that means is you're expecting the value for x1 to be typed into the keyboard, okay? So how are you going to get this to work in this program? Well, in our program, what we're going to be doing, okay, what we want to do is, instead of having these values for x1, y1, x2, and y2 typed directly into this program, we want to replace those with a bunch of cins, right? A bunch of cin commands. And I will show you exactly how that's going to work, okay? So, if you think about it, right? Cin by itself is basically having the computer sit there to wait for a number to be typed in. Now, if I put in a bunch of cin commands in this program, does whoever's running this program know exactly what's being expected? Okay? The answer is no. So what you have to do is you have to tell or give some kind of prompt, right, to alert the person running the program that the computer is expecting the values for for x1, y1, x2, y2 to be typed in, okay? So what happens is you must combine those cins commands with a cout command, where the cout command kind of gives a message, right, telling the user to type in certain values, and then the cin command then accepts those values, okay? So here's how you would do that. Here's one way, at least, of doing it, okay? So now, in that line, I would modify it. Now I would just take out those values that were specified, those initial values. I would just make this double x1, y1, x2, y2, right? Notice I removed the parentheses with the values because I don't need those values anymore. I'm going to be asking for those as input, right? And side 1, side 2, and distance, right? And now, where should I put the cin commands, right? Think about that. They have to be put in, right, before I do any calculations, okay? So I've had students in the past who stick them towards the end of the program, right? And the reason that won't work is if you look at this, right after I declared or defined my variables, I start doing my calculations. If I don't have any values for x1, x2, right, y1 and y2, then how do I do these calculations? I'll get errors, right? I'm going to get error messages. So what I need to do then is get the values for x1, y1, x2, and y2 before I do any calculations. Everybody see that? Okay, so that means right after I declare it, I'm going to put a cout command that might say enter x1, right? And I put a little colon there where it's to show it's expecting a value. And then I do cin x1. So think about how this is going to work, right? When you run this program, there's going to be that cout basically puts this little message up on the screen that says enter x1. So once the user sees that, now they know, right? The computer is asking for a value of x1. So what are they going to do? They're going to type in the value, hit enter. And what happens to that value? The cin command says take that value, right, and set x1 equal to that value. So that's how Cn works. Okay, and then you're going to repeat this then for y1, x2, y2. All right, so repeat it. And once you've got 4 sets of these, now you have all your values, right, for x1, y1, x2, y2. So that's one way of doing it, right? But Cn also allows you to string multiple inputs together, okay? So another way of doing this, okay, is something like this. I'm going to say, in my cout command, I'm going to say enter x1, y1, x2, y2. Okay, and now my Cn command is going to be x1, y1, x2, y2. Okay, because now with that cout command, the user sees that message and knows they have to type in 4 values, okay, in that order. So what are they going to do? They're going to type in 1 value, right? And they could either hit the enter key, it doesn't matter, and then type the second value, hit the enter key, the third value, enter, fourth value, enter, right? Or C++ will allow spaces and I believe semicolons and tabs, right? So basically, as long as they enter in 4 separate values, then it will work. Okay, what C++ will not accept, I believe, is commas, right? Anyway, so now this allows them to enter in 4 values all at once, okay? And then all those 4 values will be stored in x1, y1, x2, and y2. All right? So that is how Cin and cout work, okay? This is what we refer to as input-output. And these are very important commands, right? Especially for all the programs that you're going to be writing. All right, so with that, I will end this lecture, okay? But that's not all of the material for this week, okay? So there's going to be a second video that's posted up, and that video will show you exactly how to type in and run a program using the Microsoft software. I'll also discuss where you can get the software, right? And then what we're going to do, okay, in that second video is I will show you how you actually type in this sample program, right, where you're going to calculate the distance between 2 points, okay? You're going to do that, and then we're going to modify that program, right, in the way that we just showed here, right, where you're going to ask for input and output. And of course, we'll also put in specifying some decimal places for our results. Okay, so even though I'm signing off on this video, okay, make sure you also check out the accompanying video for this, right, that shows you the Microsoft software. All right, so let me end this lecture right here.